so I hope, have to deal with uploading. And we are now recording. This is the weekly meeting for Sig Docs, October 16th, 2018. And this is Jennifer Rondeau hosting because Zach Corlison is out sick today. So let's get started. Do we have anybody new on the call? I'm not looking at the full list at the moment, but it doesn't look as though we do. We do have new reviewers and approvers. I think, Jim, I saw you on the call, right? Thank you very much for stepping up. And I think we can move straight into the agenda. And Andrew, you asked to go first with the funding modeling. So take it away. Do you want to share?
I think Dominic will. So last week we asked what topic people wanted to see next. So it sounded like high availability was the winner. So Dominic has a presentation prepared. Go ahead and take it away, Dominic.
Okay, I will stop sharing so that Dominic can.
Hey, good morning, everybody. So let me share.
Good afternoon for some of us.
Fair enough. Here we go. Just a quick check. Can anybody see the screen?
Yes.
Yeah, we can see it.
Wonderful, thank you. So today in Fun with Modeling, we want to talk about my favorite topic, actually, about high availability. And once again, just as last time, interactive. Please don't be shy. Ask questions at any time, and I may ask a question or two during the presentation. So first off, when we talk about high availability, we want to set the stage. And there are usually two concepts surrounding responsive systems. One is scalability and one is reliability. So scalability is generally defined as responsiveness in the presence of load on the system. And reliability is defined as responsiveness in the presence of failure of system components. So in this presentation for this talk, we want to focus on reliability only. That is the ability of the system to be responsive in the presence of failure. So the first fundamental distinction that I want to make is that the reliability of Kubernetes does not imply the reliability of applications hosted on Kubernetes. Kubernetes may be able to sustain node failure or pod failure. That does not immediately translate into your application being able to withstand that failure. Simple example, if I publish my workload or deploy my workload as pods and the node fails, then Kubernetes will keep being responsive, but my application will not be responsive. So in that case, I would have to deploy my workloads as replica sets or deployments in order to take advantage of Kubernetes high availability and have Kubernetes reschedule my application workload that just failed. However, that still doesn't protect me if my application has inherent bottlenecks or inherent single points of failure. So we need to make this distinction. So first, let's look at the high-level architecture, as it is important in this conversation. So we have two sets of components. We have the master components and the node components. The master components, they host the kube controller, a process that hosts all core controllers, the kube scheduler, process that holds the scheduler, kube API server, the API server, and an etcd node. Whereas on the node components, we have the usual suspect kubelet and the container runtime. Of course, we have other components like kubeproxy, cAdvisor, but for this we can skip this. And Now, if we want to talk about high availability, actually that is also true for scalability. The one ring to rule them all is redundant deployment. So in order to withstand the outage of a component, we deploy multiple components, or the same component, we actually deploy the same component redundantly. So in the case of Kubernetes, that would result in this architecture. We have multiple nodes and we have multiple masters. And so because a node cannot connect to a master directly because the master is the one that may fail, we have to add an indirection. In that case, that is the load balancer, so that the node connects to the load balancer, and the load balancer will then forward traffic to an available master. Now, quick show of hands. As I said, this is all about reliability, but since we have a load balancer in there, does this setup also increase scalability of master components, or does it not have an effect on master components? Any takers?
Sorry, Dominic, ask the question again. You went not quite where I was expecting, so I got distracted.
Fair enough. Since there is a load balancer in the picture, and load balancer is a common component when we talk about scalability, who believes that the load balancer can help us scale the master components if our cluster increases? Or does the load balancer not have an effect on the scalability of our master components?
Inherently, I think it doesn't. Doesn't it depend more on sizing? Scalability? I mean, there's more variables here than just the load balancer and multiple masters.
That is correct. Inherently, it doesn't. Actually, it can get worse. If you look into how
Dominic, just so you know, I've been sort of spilling my brains on the keyboard documenting high availability for the last 2 weeks. So this is really, really timely.
All right. No, but I'm glad we nailed the timing then. So in this case, I want to quickly show the flow of requests from a client, kubelet or kube controller, to the load balancer, to the API servers, to etcd. So the client hits the load balancer, and the load balancer selects a API server at random. And this API server is co-located with the etcd leader. See in the upper picture that the request and the response flow is absolutely straightforward. However, the lower half of the picture, you see that in this case, the load balancer chooses another API server that is not co-located with the current etcd leader, but with an etcd follower. Therefore, the etcd follower will not answer the request directly, but will redirect that request to the leader and then reply on the leader's behalf. So our bottleneck, no matter how far we scale out API servers, is etcd. And indeed, the more etcd nodes we have, the worse the performance will be, because etcd needs to reach consensus, and consensus is an inherently chatty protocol. Therefore, increasing etcd nodes will decrease the throughput.
Okay, Dominic, I've got a question for you here.
Please.
And I well, you know what they say about guessing. I'm really not sure the answer. So you can set up a highly available cluster either with stacked masters, so that the control plane node is running on the same machine as the etcd node, or you can set it up with a separate etcd cluster. Does that make a difference here?
Not much. So you're right. There are multiple deployment scenarios. However, it doesn't make much of a difference because the etcd cluster will always be your bottleneck.
Yep.
So you cannot scale etcd horizontally. You have to scale the individual nodes vertically. So give it a bigger node, give it a bigger machine, give it faster hard drives. You can scale up, but you cannot scale out.
Right.
However, now that you're deep into the topic, this is actually what I'm showing here is an oversimplification. It always holds true for write request, anything that is state modifying. You do have the chance, so, to start Kubernetes with either a quorum read or not. If the quorum read is true, any follower will always redirect read requests to the leader. However, if it's not true, the follower may respond to requests straight from his local cache. However, you may actually get stale information. So you may read old data. And if you do that rapidly in a row and the load balancer spits out random etcd followers, the same query may actually lead to different results over time. So then let's do a quick deep dive into the architecture of Kubernetes high availability. So you see, we still have the load balancer, and we have individual nodes hosting the master components. In that case, 3 are depicted here. We have the kube controller and the kube scheduler, just as before. But in this case, you also see that Kubernetes needs to select master components. Needs to select leader components. The kube controller and the kube scheduler work on global shared state, that is in etcd. If you have multiple kube controllers active at the same time or multiple kube schedulers active at the same time, they may actually be competing. This is not true for the node components. Nodes or the kubelet actually works on inherently partitioned data. Since a pod is assigned to exactly one node, right, there will be no competing updates. In this case, since we're working on global state, there may be competing updates. So Kubernetes has a leader election for the kube controller and the kube scheduler. As you see here, kube controller and kube scheduler, the leader can actually end up on separate hosts. However, etcd guarantees you that at any point in time, there is only one of them. The leader information is stored as Kubernetes endpoint objects in the kube system namespace. And there is an annotation that is holder identity, and the holder identity will point to the kube controller or kube scheduler that is the current master. And Kubernetes implements leader election on top of endpoints and on top of etcd. etcd guarantees the consistency of it. And this is a simple depiction of how the leader election works, fairly standard leader election. On start, any master will run this loop, trying to acquire a lease. If a lease is not acquired, then the master will keep retrying. One of the masters will acquire a lead, and then executing its main functionality. In case of the controllers, it will host the controllers. In case of the scheduler, it will host the scheduler. And it will keep trying to renew the lease as long as it still has the lease. It is still the master. And once it loses the lease, it is actually a hard kill of the process. For example, kube controller. It hard kills itself. And via operating system mechanisms, like for example, systemd, the process restarts, starts again, and enters this loop again. An interesting side note, is that etcd guarantees you that at any point in time there is at most one master, either at most one leader kube controller or at most one leader kube scheduler. However, that does not prevent the individual components from falsely believing that they are still the leader component while they are not. that is a situation where at one point in time you can actually have two competing leaders. This is also referred to as split brain. Typically, split brain is it's an unavoidable condition. However, you can guard against it, typically with, for example, fencing tokens. However, Kubernetes does not apply any of those guarding mechanisms. So for a brief period of time, you may have two competing masters. That may lead to situations where you have a replica set that specifies 3 replicas. At time t, you have 0. 2 of the masters are online, believing to be the leader, resulting in 6 replicas of the pod. However, down the road, the reconciliation loop will take care of that. This is an interesting side note, since Kubernetes actually doesn't give you any guarantees, with, for example, replica sets, that it will create only up to 3 pods. But it basically only gives you the guarantee that over its lifetime, it does its best to keep it at a steady state of 3 pods. So while high availability actually helps to keep that guarantee, there may be situations where you do see jitter. Now let me see, we do have, yeah, unfortunately. This one was animated, but that one doesn't work out for me right now.
Try going into presentation mode or bring up the image in preview.
I just bring it back. Here we go. Yeah.
There we go.
They're trying to acquire the leases. The leases is being renewed over time. As long as the release is renewed, this master is executing. Eventually it loses the lease. It stops executing the main loop. And then the entire game starts from the beginning. So that was it today for high availability. If there are any questions or comments, be more than happy to try to answer.
So I think last week you talked about high ability Kubernetes. How much does Kubernetes do? Not much, I think was what you said. What was the not much?
The not much is, if you look again at this picture, you take the load balancer away, or you take etcd away, and the entire architecture crumbles on you. So the load balancer needs to be a highly available load balancer. Kubernetes does not provide that. It just requires the presence of it. And etcd is the one that actually provides the consistency of the data, and in this case also of the master. And yes, Kubernetes does have its own leader election, but as I said, since it is it doesn't guard against split brain situations, it is, what's the right word? You could argue it is suboptimal in a situation that requires consistency. That would be unacceptable. However, due to its reconciling nature, Kubernetes can actually deal with these situations down the road. But you see certain jitter that we talked about, for example, with the replica sets. So actually, out of the box, Kubernetes itself doesn't provide much. It stands on the shoulder of giants. That is load balancer and etcd. And it uses their capabilities sufficiently, however, not to the maximum. Yeah. But since it doesn't give you any guarantees, besides I do my best to try to reconcile the current state with the desired state, it is actually a fair architecture. But in and of itself, there is not much Kubernetes adds to the high availability.
Yeah. You might have mentioned this, but does we have this idea of leader for etcd and for the scheduler and a controller manager. Is there also a notion of leader for the Kubernetes API server?
Actually, I did not mention that. That is a very good question. No, there is not. So the etcd leader is correct. It's an inherent capability prerequisite actually of etcd. So etcd will guarantee you that there is only one leader at any point in time. Since the API server is, you could say, a proxy on top of etcd, there is no need to elect a leader for the API server.
Right.
Whatever API server the load balancer chooses to forward the request to will do just fine. It will then eventually forward, especially if it's a write request, etcd will forward that request to the current etcd leader no matter what API server was selected.
Right, yeah. And you mentioned that the load balancer is not necessarily highly available, but the load balancer is not something Kubernetes provides us, right? Isn't the load balancer something that as you implement a Kubernetes environment, you'd have to figure out how to do that?
That is correct. I did not want to say that the load balancer is not highly available. It's a prerequisite. It needs to be a high availability load balancer.
Right, yeah.
So, and yes, you are right. That is something that is a prerequisite for Kubernetes, but Kubernetes doesn't provide it. Whether you're on AWS, Azure, Google, whatever comes with the hosting platform needs to be integrated into your deployment.
Yeah, and I've noticed, I don't know if this is true for different kinds of ingress controllers, but in GKE, the ingress controller has this same trouble, is that it needs to elect a leader. And if it doesn't get that right, there can be some of these problems that you're talking about.
Mm-hmm. So in general, however, that is a separate topic for a separate discussion. However, to brush on to that, Kubernetes has some implementation choices around how to host core controllers and how to host core schedulers. That is a kube controller manager process and the kube scheduler process. Custom controllers or custom schedulers do not plainly fit into this view. So various controllers as a concept are an extension point, right? You have a replica set, you have a deployment, you can have anything else. They're an extension point. Kubernetes makes a difference in how it hosts core controllers or how it hosts custom controllers. And therefore, you will run into these problems because custom controllers cannot take advantage of the entire already existing machinery.
Mm-hmm. Hey, I have to head out to another meeting now, but thank you, Dominic. I'll talk to you guys later.
Thanks, Andrew.
Bye.
Bye, Andrew.
Okay, thank you. That just was really, really helpful.
Yes, thank you very much, Dominic. Any other questions? Okay, I believe the next item up is...
Thank you very much. Sorry, I say bye-bye too. Need to head out to the next meeting.
Okay, thanks, Dominic.
Bye.
And I think the next item up is GitHub project cleanup, which is yours, Steve?
I don't exactly know why my name is there on that one. Does anybody know? Was I assigned GitHub cleanup?
We talked, my recollection of last week's meeting is that we talked about using a project in the Kubernetes organization to manage a content cleanup. And we've also got a few projects in the website repo.
Now I remember now. I didn't get to that between last week and this week. So.
And I'd completely forgotten about it until I saw this item on the agenda. So perhaps we should defer to next week.
Yeah, I will. I'll put it on in my list of things to do between now and next week. I remember now. It was trying to get all the different projects that collect issues consolidated.
Yeah, we've been kind of random. We've been unsystematic in how we use the projects in the website repo. So I think the idea is to start figuring out more system there, and to think of it in terms of like sub projects of the master project that lives in the org. That's my recollection, anyway.
Yeah. Okay. Yeah.
Cool. And Steve, I'm happy to take a look at things if you want to rubber duck or brainstorm, since Zach and I have been talking about the larger content cleanup, content focus stuff also.
Sounds good.
Cool. Thank you. In that case, the next item on the agenda is Luke's to talk about Sig Docs tools. And it's Mary Band.
Hello. Okay, cool. So yeah, I don't. In terms of an action item, it's kind of more of a discussion item, which is, so we have this. We gathered together this group of Sig Docs tool folks. So myself, Andrew, Zach, a couple others, and now I'm curious if the group has any input on what exactly we should do with it. Thus far, we've mostly just been kind of having ad hoc conversations on Slack about various things, and we've responded to a couple small action items. But I guess I'm here to get input from the group, not just about logistics and how our subgroup should run, but also what our priorities should be. If anybody has any action items that they'd like to request, and so on and so forth. So I'm just opening up the discussion.
Anybody? Our group has shrunk pretty significantly here, but Jim, Steve, Svetlana, got anything?
I'm sorry, I was multitasking here.
Svetlana, I didn't mean to put you on the spot.
Yeah, maybe given that I think I'm the only person in the Sig Docs tooling group who's here, and given that we have some key players out for the week, maybe we should just shelve for next week.
Sounds like most of the agenda is headed that direction, which is fine with me. And I'll give it a little bit of thought too, not because I want to be part of the working group. I don't. I need to sit on my hands here. I'm interested, but too many other things. But I think it might also be useful for those of us who aren't planning to be part of the group to ponder a bit more. Some of this stuff is already laid out, I think. The kinds of sort of tooling and infra issues that we have been thrashing around as a larger group, to make sure that those are clearly defined for your group, Luke. I mean, some of that is sort of legacy Hugo migration pain and is largely cleaned up. That's why I need to go away and think about it and can't just brainstorm on the spot. But does that make sense to the rest of you?
Yeah, it does to me.
Yeah, no, I think it's a good idea, and I'd second that as Jim. And I'm thinking that a good first step for the Sig Docs tools would be to just outline what tools are available and the current issues, kind of echoing what was already said, and then come up with a roadmap based on that.
Yeah, if we could have a list of things that have been batted about casually, that would be cool.
Okay, yeah, because I think, it's one of those things where we have all these different platforms and sources of information, and nothing to really, not yet any means of really centralizing that information. So I think maybe like in the next week or so, I can give that a little bit of thought. I wonder if maybe like issue tags could be the primary means of coordinating this information, or maybe we should set up a separate project, so on and so forth. But yeah, maybe we can either talk about that next week, or I can come with a presentation, something of that sort.
One other thing occurs to me too, because I've been just dipping my toes in pull requests this week, and there was one against the Travis build I didn't look at it carefully because I thought, okay, not my pig, not my barbecue. Somebody else needs to wrangle this one. But I was curious about it because historically the Travis build has done other things from what the this particular PR was suggesting that I do. And if we had a place, like a way of tracking related issues so that PR wranglers who aren't necessarily going to step into those PRs and wrangle them, but who need some context to figure out how to sort of point them at people. Yeah, I guess that's really, really a long-winded plus 10 for your issue labeling, Luke.
Okay, well, that's quite duly noted.
So Luke, is one of the things this group is looking at is the automatic generation of reference docs?
Yeah, that's something that Karen Bradshaw, who and I think a couple others have expressed interest in. Yeah, I mean, basically, I do think that very much falls under our umbrella,
Yeah.
which at this point is basically everything that's not writing and thinking about content kind of falls under our umbrella. So yes, that's the long-winded answer.
Okay, good. Yeah.
Yeah, that one we keep getting questions about from other SIGs.
Mm-hmm.
Yeah, I would love to, I don't know, designate a point person on that, or at least maybe, get some kind of Google Doc or something from somebody, because I don't even know where to begin comprehending the scope of the problem or understanding the trade-offs and challenges that have been considered thus far. Love to have an information source on that.
Yeah, and another person to bring into that conversation is Chiming, because he's done the most work recently to rewrite stuff and sort of corral and wrangle it. And there's still, I know around the bit that I know the best, and I don't know it well. I only know the issues. The Kubernetes docs for 1.9, the SIG cluster lifecycle generated them. And for 1.10, I'm not sure what happened. 1.11, things were, I'm still not sure what happened. 1.12, for sure, Sig Docs generated them. And it appears that we've taken that over. And that's now part of the generated docs responsibilities and part of the scripts. But that story alone suggests that we need to pull more bits together in terms of the story we tell to other SIGs also. Okay.
So maybe now that I think the Hugo migration stuff is out of the way, and I think some of the other pain points are out of the way, maybe we can target that as our P0 for the coming weeks and months as a group, as a subgroup rather.
Sounds like part of a plan to me. So the only other item on the agenda is Brad Topol's presentation, and he couldn't attend today because he's otherwise occupied. So does anyone else have anything they want to bring up? Or shall we take back 15, 20, 25 minutes? Going once, going twice, channeling Zach here. Okay, also channeling Zach here. That's a SIG meeting. Thank you, everybody.
All right, thanks, bye.
Thanks.